Professor, Professor,
Oh, yes.
morning.
What? Excuse
Professor,
me?
when
Yes.
will be
What? What did you?
what is the time for the quiz?
For the quiz, right?
Yes, the quiz. When will be the time for the quiz?
In the second period, okay? Second period. Yeah. I think, let me see. Now it's 8:30, then around 10, right? Around 10. Okay? And, okay, yeah. Today we still have to, at the first period, we still have to finish the experiment number 7, right? And then we will have a quiz on the second period, right? So let us switch to our PowerPoint, okay? Mhm. Okay, and can you see the PowerPoint right now?
Yes, we can.
Okay, and yeah, the experiment number 7, that's code converter and decoder. That last week we already talked about a part of it, right? Just like okay, that's our objective of the design and implement code converter, right? And the introduction, okay. Then last week we did 8421 code. Okay, we convert 8421 code to 2421 code. Use the we use we use the SOP, right? The sum of product format to convert. To use the name gate. Okay, we use yeah, use name gate, right? So that's introduction here. And okay, yeah. The code conversion design procedure. So last week we just followed we use the name gate. We followed the step to use the name gate to finish the uh, converter. But we still have the other part. We could use a NOR gate. Okay, then now talking. Well, we were talking about this part, right? Okay, so let me turn off the video, right? And then that's the 8421 code, right? Maybe I have to um, copy one. And then because last week we already talked about this part, right? The because we use a SOP, that's a sum of product, okay? That's a sum of product form, okay? It's just like the K map for sum of product. So that's last week we already talked about how to convert ABCD, that's input, okay? ABCD is input, and how to convert the ABCD into the W, X, Y, and Z. Okay, so ABCD, that's A421 code, and W, X, Y, and Z, that's a 2421 code, right? So, so that's the W, how to convert the A, B, C, D to the output W, and how to convert the A, B, C, D to X, and also how to convert the A, B, C, D to Y, and convert A, B, C, D to Z. All right, so that's last week we talked about, we used the sum of product, okay, to design the uh, circuit. And then we, after we got the Boolean, the sum of product, okay, equation uh, from the sum of product. But we have to still have to convert it into just like we could use a NAND gate, right? Just like uh, this one B NAND C, this one is B NAND D, and this one's A NAND A, right? So that's a NAND gate, right? So we can use a 3, 1, 2, and 3 NAND gate. Up to the 3 NAND gate, we still need another the last NAND gate. So total is 4 NAND gate to convert ABCD to W. And also we could use a 4 NAND gate to convert ABCD to the X, and also for the other Y and Z, right? So after that, we draw the circuit like this, right? We draw a circuit like that. So again, you can see that W equal to, okay, the first one, that's B and D, right? B NAND D, sorry. B NAND D, right? And the second A NAND A. And then the third one, that's B NAND C. So that's equal to the, not this one, right? That's equal to this equation, okay? B NAND D, B NAND C, B A NAND A, right? So that's the first NAND gate output, okay? First NAND gate output. And the second X, the first input, that's B NAND C, right? B NAND C. And the second, that's still B NAND D bar, okay? B NAND D bar. And third one, still A, right? A NAND A, right? Okay, so that X. So A NAND A, B NAND C, and B NAND D bar, right? And third one, that output equal to Y, right? So that comes from A, okay, A NAND A, right? And the second, that B bar, NAND C. And the third one, that's come from B, okay, this middle one is B. Then C bar, B, C bar, and the last one D, okay, B, C bar, D, okay, so that's coming from see, A NAND A, right? And the second, yeah, the last one is a B NAND, B NAND C bar NAND D, and and then B bar NAND C, okay, so that's yeah, that's one A, okay, and B bar and C, right? So that's output equal to Y, right? Y uh, converted. So that's ABCD converted into Y. And the last one D, a Z, that's equal to D only, right? That's equal to D only. Okay, so that's Z. So last week we already used the multi-sim to do the simulation for you to check to verify the circuit, right? To verify the circuit. So the circuit is correct. And then today we have to talk about how to use the product of sum, right? It's still, maybe you have to copy to, maybe it will be easy to switch, right? We still have to use the A421 and convert it into 2421, right? But this time we use a product of sum. So last time, okay, for the name for the sum of product, we use the one, right? We use one for to fill to the Kmat, right? We choose one to fill to the Kmat, or that's the same. Right? Maybe you can see that one or zero. That's the same. We fill into the Kmat, just like the first for the first W. Okay, for W, the 0, 0, 0, 0, and then 0, 1, 1, 1, 1, right? So you can compare to this one, 0, 0, 0, 0, and 0, 1, 1, 1, right? And then the D, 1, 1, D. Okay, so that's the same, right? D, 1, 1, D. So how to filter the Kemet, that's just still use the same method. And and also for the X and Y and Z, that the step it's the same, right? You just follow the okay, just follow the and yeah, from 0 to 15, okay, from 0 to 15. That's start from 0, 0, 0, and then that's 0, 1, 2, 3, okay, 0, 0, 0, 0, and then 4, 5, 6, 7. That's 0, 0, 1, 1, okay, sorry, 0, 0, 0, 0, okay, 0, 1, 1, 1, right, okay, so when we fail to the K-map, start from that APCT. Okay, so APCT will start from the top to the bottom. So 0, 0, 0, 0. Right, that's a 0, 2, 0, 1, 2, 3. Okay, and then 0, 1, 2, 3. Okay, so and then 4, 5, 6, 7. So that's 0, 1, 1, 1. All right, and then next one from 8, 8, 9, 10, 11, 1, 1 DD, right? So 8, 9, 10, 11, all right? So that's a 8, that's 1, 0, 0, 0, right? 9, 1, 0, 0, 1. 10, 1, 0, 1, 0, that's 10. And then 1, 0, 1, 1, that's 11. Okay, this one is 11. So 1, 1 DD. And then the last four, is still all that are all of the last four 12 to 12, 13, 14 to 15. Uh, all of them are D. Okay, that's I mean don't care. We don't care because the we don't have that 2421 code. Okay, 2421 only from 0 to 9 only, 0 to 9. Okay, but 8421 that compared to our decimal number that's from 0 to 15. But 2421 only 0 to 9 almost, right? So we don't care the 10, the input, okay? We don't care about the input from 10 to 15. Wait, we don't care. Why? Because 10, 11 to 15, they don't have the corresponding uh, 2421 code, right? They don't have the corresponding 2421 code, so we don't care. If you input 1010, then we don't care what is the output, right? We don't care the output. Or or if you want, you could block it. Okay, you could block the 10 to 15. Okay, when you input 10 to 15, then no output. You could give it 0, right? You could give all of this one equal to 0, then no output. But just like I said, if we want to simplify the circuit, then we just put don't care. Okay, if we would, whatever they show 0 or 1, right? And so that's the first one, the W, right? And also for X, Y, and Z, you just follow the order. Okay, you just follow the order 0 to 15 and fill the the digit, the number. Okay, the binary number into X, Y, and Z. Okay, same thing. From this one is 0, 0, 0, 0, and then 1, 0, 1, 1. Okay, So 0000, and then 1011. And the third from 8, that's 11DD, and then 4D, right? So that's 11DD, and then last four still D, okay? And why? Yes. Uh-huh. Any question? No? All right. So why is the from 0 to 4, 0 to 3, that's 0011. And then 4, 5, 6, 7, that's 0100. Right? So this one, 0011, and then 0100, right? So from 8, 11 DD, and then last four still D, okay? So in there, 11 DD, and last four still D. The last one, Z, that's a 0101, 0101, right? And then 01 to 9. And the last six is equal to D. So for Z, that's 0101, okay? Don't forget the 012. This was 2, 3, okay? So 0101 and 0101. And 8, 9 still 01. And from 10 to 15, that's D. So this time, right, because we use a product of sum. So this time we circle 0. Last time we use a sum of product, we circle the 1, okay? The adjacent 1, just like the 4 adjacent 1, and there's 4 adjacent 1, and there's 8 adjacent 1, right? But this time we have to, because that's a product of sum, so we have to circle the adjacent of 0, right? Just like only there's 2, right? Adjacent 0, okay? And there's 4, 0, there's 4, 0, okay? We circle 4, 0. And maybe you will ask me, how about the other? The D don't care, right? And this one don't care. We don't need to circle it because that's been don't care, right? So if we circle it, then we have to add another item. So that will make our circuit uh, become more complicated. Okay, so we try to simplify, so we don't need to add more item. So we don't circle the D. Okay, we don't want to circle the D. And the second one, that's still we circle the first four, 0, and then there's 2, 0, right? And the third one, Y. Okay, Y that's 2, 0. Okay, that's 2, 0, and then the top two and the bottom two. Okay, that's still 4, right? 0 D, 0 D. Okay, that's this 4 still we could treat it just 4, 0, right? And also there's 4, 0. Okay, that's 4, 0. So that, and here the D we could treat like 0, because if you just circle 2, 0, then that's a 3 variable. Okay, you just eliminate one variable only. So if we could circle 4, 0, then we could eliminate 2 variable. Okay, the same thing for the top and the bottom, right? And this one, the last one, we could circle 8, the top 4 and the bottom 4. That still only have one variable change in this two row, right? This one 0, 0 and 1, 0, right? So C is changed. And also A, B, C, A, B, A, B is changed, right? A, B is changed. So we could eliminate A, B, C. So Z equal to D, right? So that means Z equal to D. And then we go back to W and here, because we circle 0, right? We circle 0. So for the, we could eliminate 2 variable for the 4 adjacent 0, right? Because AB didn't change, okay? AB always 0 for the 4, 0, right? And for the C and D, then, okay, C and D, we is supposed to change, right? So we could eliminate two variable, C and D. So we uh, only A and B no change, right? A and B no change. So we keep the A and B. That because that's a sum, oh sorry, product of sum. So the first item, the 40, that first item, that's A plus B. That's mean A or B, not A and B, okay? Because that's a sum, okay? We have to do the or, that's mean or, okay? That's mean or. So A or B, A or B, that means sum, right? That means sum. And the second, the two are just a zero. That, the first one, C and D, no change, right? C and D, no change. A, no change, right? A from 0 to 0, so A, no change. Only B from 0 to 1, so we could eliminate B and keep C, D, and A. But that's yeah, C, D, and A. So that's A plus C plus D. Okay, A plus C plus D. And this time you cannot, maybe you will think, do we have an add a bar? No, because we use a product of sum. So the zero, um, that's a that's mean what? Okay, yeah, because we circle the adjacent zero, and and zero that's mean because we use NOR gauge, so zero was supposed to be a positive, right? If one that's been negative, so if one that's been we have to add a bar, okay, just like this one, right? Just like this one, C and D, okay, C D and then A, right? So A plus C plus D bar because the dA equal to 1, right? D equal to 1, so that's D bar, right? So A, that's 0, right? So A. And then C plus C and plus D bar, right? So that's this item. And this one still A plus B. This one still A plus B. And then CD, okay, C plus D, C plus D. And A plus C plus D, right? So that's W, that and X, right? And then Y, okay, for Y, let's see the first, there's two, right? There's two, A and B, A and B no change. And also C no change, right? Only D change from 0 to 1. So we could eliminate D, but A equal to 0, B equal to 0, C equal to 0. So that's A plus B plus C. Okay, so that's the last item, A plus B plus C. And for the top and the bottom one, right? For the top and bottom, A is changed, right? A from 0 to 1. B bar, no change, because 1 that's been B bar, okay? 1 that's been B bar. So B bar, no change. And also, D no change, okay? D no change. C change, right? C is change, right? C is change from 0 to 1, but D still kept, it's still equal to 0, right? The from top to the bottom to and the bottom one, that's 0. So that means B bar plus D, okay? B bar plus D, that's the second item. and the green circle, okay, the green circle for the still B bar, yeah, A is changed, so still B bar, okay, only B bar for the there's two row, and for the there's two, sorry, for there's two column, for there's two row, C no change, right? C bar no change, but D is changed, right? D changed from 1 to 0. D bar, C bar no change. So mm, B bar plus C bar, okay? B bar plus C bar. So that's the first item, the first item. And this one we just talk, just talk about this one for first one, first time. So that's Z equal to D, okay? So according to the uh, equation, so we have to this one just we need to use OR gate, right? We need to use OR gate to do to implement the equation, right? To implement this equation. That's OR gate. But for our for our design, the second step, right? The first step fell to the K-map, right? And then second step, find the minimum Boolean is expression for the product of sum. So that's the second step we just finished. And then the third, we have reduced the Boolean form to NOR gate. Okay, this time we have to convert it into NOR gate. Last time we have to convert to NAND gate. This time we have to convert to NOR gate. So still the same step. We have to add C in here. Okay, that's the first W, right? A plus B, A plus C plus D. So we add a 2 bar on top of it, right? So that's still equal, okay? Still equal. So we add a 2 bar, that's still equal, right? And then we try to break, right? Try to break the bar in here because we use NOR gate, right? We try to use NOR gate, not name gate, okay? We don't use name gate. We try to use NOR gate. So we have to break the bottom bar, okay? Because the name NAND, right? A plus B NAND A plus C plus D. But if we break it, then it becomes plus. That's OR, okay? And still have a bar on top of it. So that means NOR. Okay, so the at the first one, that's A nor B. The second item, A nor C nor D. And then we add another nor to nor. There's two items, right? To nor, there's two items. And that's the first W. For X, for X, A plus B, and then A plus C plus D. Still, we add the 2 bar on top of it, and then we break the second bar, right? Because we have to uh, convert the NAND gate into NOR gate, right? So we break it and then we become is plus, right? That's the according to the De Morgan theorem, all right? So yeah, so that's the first one, first item, that's A nor B. The second item, that's A nor C nor D bar, okay? And then use another nor to plus these two items together. And Y equal to B bar plus C bar, B bar plus D, and A plus B plus C. So we still add a 2 bar on top of it, right? If we break the bottom bar, then it become a plus, right? Just like here, okay, we break the bar and we break these two item, the bar, so it become plus. Okay, so that first item equal to B bar nor C bar. The second item B bar nor D. The third item A nor B nor C. Okay, and then we use another NOR gate to add these three items together. So we got Y, okay, and then Z. But I didn't draw the figure for this one. Okay, I didn't draw the circuit for this one because I don't want to implement this circuit. I just go through it because in our menu have talked about both, right? One is uh, sum of product, and also it talk about product of sum. So yeah, in our menu it talk about both, right? Sum of products and also product of sum. So that's why I have to go through it, but I don't want to draw the circuit. I don't want to do the simulation on multi-sim because that will make you confused. Okay, because you just beginners. I will want you to focus on the sum of product. Okay, try to focus on sum of product to design the circuit, right? And also just like I add the after we finish this one, right? After we finish the product of sum, and then the code converter, okay, B, that conversion design procedure, the same thing, right? We started the preceding design procedure in detail, show through Boolean algebra how the function W in terms of sum of product is reduced into name operator. So it just repeat, right? Just repeat that we already did in last week in here, right? That already did in here. So you just go through it very quickly, okay? Show show also by Boolean algebra how the function W in terms of product of sum is reduced into NOR operator, right? So that's we just talked about the W in here. Okay, how to use the NOR. Okay, and then the design problem. Okay, the design problem. The first one at your assignment number 4. I told at the in the beginning of this semester, I told you we have 4 report, right? We have 4 report. So this one is last one, right? This one is last one. Uh, the lab assignment number 4. You have to design an XX3 to 8421 code. Okay, A63 to 8421 code. Hmm. And then show all the steps in the design procedure and reduce the logic equation into 2 level. Uh, okay, that because that's a design program, right? Program. So it asks the question asks the student A, you have to use name gate. Okay, use name gate realize, and also use NOR gate to realize the converter. All right, but later I will tell you our lab assignment. Okay, we just read it first. Okay, draw the complete logic diagram for 2 level name realization show in your diagram how you would obtain the input A, B, C, and D and their component complement. Okay, and their complement. Implement your circuit and verify its operation. Demonstrate it to your instructor. All right, that's a question, right? That's a question. But for let me see the second. Okay, second, that's a design of 4-bit gray to binary code converter. Gray code to the binary converter. Okay, using only 3 input exclusive OR gate. Implement the circuit, verify the operation, and demonstrate it to your instructor. That's the second, right? And then let me see the other. Okay, that's our lab assignment. So I just tell you how design the problem number one of the experiment number 7 on page 20. So because I have one more, this one I have to delete. Right. So that's page 20 in okay, sorry. Suppose 19, right? Okay. Yeah, 19, right. Page 19. Right, so from the page 19. Okay. Right, and then the design an XX3 to A421 code converter. Show that's the same thing, right? Show all steps in the design procedure and reduce the logic equation into two level. Okay, only two level. But I only ask you to do the NAND realization only, right? You don't need to do the norm. Just like I said, that will make you confused, right? So just focus on the sum of products, okay? Sum of the product. So just use NAND gate to implement the circuit. And then draw the complete logic diagram with a multi-sim, right? With multi-sim for two-level NAND realization. Okay, use word generator. Okay, in here I ask you to use a word generator for the input of XX3 and use 4-channel oscilloscope for the output of the A421. Yeah, input is XX3. Okay, output is A421 code, right? A421 code, and simulate and then verify the circuit operation, right? The experiment report. Okay, the due date is November 12th. So next week, right? You have 1 week to finish the experiment. But now I'll try to, oh yeah, that's a report documentation, right? Report documentation. You still have to write the objective and then also the introduction. I already give you give you the template, right? You could follow the template to write your introduction, just like list the XX3 ABCD to A421 code, choose table. Yeah, you could just copy, not this one, okay, XX3, right? Sorry, okay. XX3, right? And then A421, okay, just like I did in here. XX3, you put it in A, B, C, D. Then A421, put it in the right side. That's output W, X, Y, and Z, okay? So you input this one, you put XX3. Maybe, I copy this one, right? I copy this page and then put it into we put in the last, maybe in, let me see, yeah, in here, put in here, right? So I just copy this one to the output, okay? And this one changed to A421, right? This one is 3, right? Let me see. Right, SX3 to A421. Okay, so copy the XX3. 0010101. Okay, that's from 3 to 12. Okay, 3 to 12. So just go back to here. 3. This one equal to 1. And this one equal to 1, right? And then 4. Okay, then 5. Maybe just copy, right? Suppose copy from 3 to 12, right? Okay. To 9 only, right? Okay. And then the bottom, copy the D, don't care, right?
Professor,
Yes.
are you gonna be uploading these slides to Titanium?
No.
Because
No.
nah,
No.
these ones
That's
you have up.
I just give you I just teach you in here, right?
Okay.
You have to write it down, okay? Because that's the answer. So I give you some actually because we still have some more time. So we start the quiz on 10. So I because we still have time. So I just teach you how to do it. Okay, teach you how to do it. But I, I don't want to upload the answers on to
Okay.
Titanium. Okay.
Yeah.
You could write it down. Okay, you could write it down. Right.
Okay.
Yeah.
I was gonna say the instructions to the lab assignment.
That assignment I will upload that. Right. Right.
Okay. Yeah.
That's one. Right. I have I will upload the Word file. The Word
Yeah.
file
Okay.
for you. Yeah. You could
Yeah.
just use the full
I was
Word file
talking
to-
about this slide.
Okay.
Let's slide 10 and one.
That one I
I just
will.
wanted the
Okay.
instructions.
Mm-hmm.
Yeah. Thank
The
you.
instruction I will include, I think instruction and include the documentation, right? Includes
Okay.
documentation,
Yeah.
but we will not include the answer.
Yeah. No. Obviously not. Yeah. We have to work
Okay,
on
okay.
that on our own.
I just give you some hint to how to do it. Okay, how to do it. So if you want, you could write it down. Okay, and then later you could just follow the step to do your
Yeah. I'm writing down
the
notes right
assignment.
now.
Okay. Mm-hmm.
Thank
Right. So yeah, this is exercise 3, right? This is exercise 3. So that's mean in we don't have 10 to 15, right? We don't have 10 to 15 for the input. So our input only 0 to 9 because exercise 3 is only 0 to 9. So we don't have 10 to 15. So actually, for this part, still don't care, right? Because we don't have the 10 to 15. So yeah, we just leave it, or let me see, and then A, B, C, D, right? So yeah, we only fill from 0 to 9, and also the bottom. So still don't care, right? Still don't care because we don't have the input from 10 to 15. So if we don't have 10 to 15 inputs, and then we will not have the output for 10 to 15. So we could put the don't care for 8421 code, the output, right? And then if that's the first step, right? The first step. And then the second step, we still have to use the, I just copy, right? Then put it in here, right? The second step, fill to the K-map, okay? How to fill into K-map and, okay, let me think. I have to, okay, let me try to open that. Then let me switch to the visual, right? But that, let me see. Hold on a second. Oh, right, right. That's okay. Just let me switch to the visual. But I have to put the PowerPoint. Okay, sorry. Okay. Okay. Okay, now that's a visual. Okay, that's a visual. But because my it just give me the Chinese word, so you don't need to care about that one, right? I just tell you how to fill the you get compared to the table of the XX3 to A421, all right? XX3 to A421 table, okay? So the W, the first 8 from 0 to 7, that's equal to 0, right? So that's equal to 0. So I just put it in 0. Okay, that's 1, 0. 6 and 7, right? And then 1, 1, okay, 1, 1, that's 8 and 9. And the other 6 is that don't care, right? Later we will circle it, okay? We put the second one. The first 4 equal to 0. First 4 equal to 0. And then 1, 1, 1, 1, right? And then 1, this 1, 1. Okay? 1, 1, 1, 1. And then 0, 0. There's 2. 0, 0, right? And the other 6 is don't care, right? Okay, and now we try to circle it, right? Because we only circled the 1. So this one we don't need it. That's a 0, right? Don't need it. So we only circle the 8. Okay, this 8. Because the don't care, we could treat it like 1, okay? And the middle, the X, still, right? The 8 in the middle one, right? So I did this 3. Move this 1. Right. So that's 8, right? It's 8. And that's supposed to be just like C and D, we could eliminate, right? Because C and D is changed. C and D are changed. And then also B is changed, right? B is changed from 1 to 0. So we only have keep A only, right? W equal to A. And this one, X equal to B, only equal to B, right? A is changed. C, D are changed. So only W equal to A, X equal to B. Oh, that's too easy, right?
Okay.
Yes,
Uh, can you explain again how do you put the numbers that came up?
it just follow the W, right? Okay, you have to compare with the, oh yeah, you didn't have the table, right? Uh, okay, and you could see the table on page, let me see, in page 6, okay? Page
It-
6, from page 6, right?
Yes.
Okay,
Mm-hmm.
sorry, I maybe I put it in the wrong one because uh, 0, 0, 0, 0, that's from 3 to 12. So it's not, yeah, from 3 to 12. So that's the first one, not supposed to be, don't care, right? Let me start from 3, okay? Start from 3 because the W, right? W, um, 0. Okay, let me switch back to the PowerPoint, right? It okay, well, okay, that's a PowerPoint, right? So you can see that because the this one is input, right? This one is input. So that's from 3 to 12, 3 to 12. And the output, that's 0. This one is a W, okay? The first one, first digit is it's W. So 0, 0, 0, 0, 0, 0, 0. So first 8 is 0. And then uh, 8, 9 equal to 1, right? 8, 9 equal to 1. So we have to go back. So, okay, then let me switch back to the this in here. So we start from 3, okay? 0, 0, 0, 0, that's 3, okay? Start from here. 0, 3, 4, 4, right?
Mm-hmm.
3, 4, 5, 6, 7, and 8. So this one's still 0, right? Okay, and 9, oh, sorry, 7. So 7 only, so 7 only. So 3, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 8, 9, sorry, 9, all right, this one 9. And then 10, 10 still equal to 1, right? Let me think, right? 3, 4, 5, 6, 7, 8, 9, 10. Yeah, uh, to 10, still 0, right? To 10, still 0. So 8, 9, 10. This one, 0. Okay. 11, it's 1. Okay. 11, it's 1. According to, corresponding to XX3, 11. So the W equal to 1. The W equal to 1. And 12 equal to 1. Right? 12 equal to 1. Mhm. And then for the other, just like 0 that we put don't care, right? 1, don't care. And 2, don't care, right? And then 13, 14, and 15, okay? 13, 14, 15, don't care, right? So that's what we use, right? So let's suppose that there's 4 only, okay? There's 4, and also there's 1, there's 2. Let me use the duplicate. You try to use this 2 only, right? Okay, only this 2. All right, and we don't need the other, right? We don't need the other. So only this 2 item, only this 2 item, right? And for X, still the same, right? Still X. The second row, you can see from the A4, the 4, okay? That's under the 4. So that's 0, 0, 0, 0 from 3 to 3, 4, 5, 6. That's a 3, 0, 0, 0, 0, okay? 0, 0, 0, 0, 3, 4, 5, 6. So 3, 4, 5, 6, okay? 0, 0, 0, 0, right? And then 7 corresponding to the XX3, 7, right? That's 1, 1, 1, 1, okay? 7, 8, 9, 10. 7, 8, 9, 10, it's 1, 1, 1, 1. So 7, that's 1, right? 7, that's 1. Okay, that's 1, 7, 8, 9, 10, that's 1. Okay, and then next one, 7, 8, 9, 10. 1, 1, 1, 1. And then 11 and 12, 0, 0, okay? 11 and 12. So 11, that's one, 11, right? 1, 0, 1, 1, that's 11, right? 0. And 12, 0, okay? And the other, just like 0, 1, 2, 0, 1, 2, okay? 0, 1, 2, that's don't care. And the last 3 is don't care, okay? 13, 14, 13, 14, 15, that's don't care. So let me see. That's only 2 items, right? This one, only there's 2, right? Okay, the other just in 2. You can treat this one equal to 1, right? So only there's 2 only. And also there's 2. And also there's 2. Right, so copy this one. And this one. Right. There's 3 items. Is that right? Oh, sorry. We could cover this too, right? We could cover this too. Ah, I don't have the. We could cover that. So that's a 4, okay? 4. I don't have that. I did it that. Maybe I did a copy from the other. Okay. That's 4 supposed to be there, okay? Right? Uh-uh. Okay. So that's 4. Right, that's 4. And there's two. Okay, so we have 3 items for X. 3 items for X. Right. Later we come back to this one. So let me switch to the hmm, next one, right? Okay, let me see the other. And then, okay, let me see. Right, that's Y and Z. Okay, Y and Z. Still, we have to uh, compare with the page 6, right? Page 6. So, mhm, you under the 2, okay, under the 2. So that's corresponding to XX3. Okay, so start from 0, start from 3, okay, that's 0011, okay, 0011, start from 3. Then we could put 012 equal to D first, right? 012, that's D. And then 0011, okay, this one equal to 0. 4, 0, 0011, 0, 0, 1, 1. Okay, right. And let me check it again. 0, 0, 1, and 1. Okay. That let me check it. 0, 0, 1, 1. 3, 4, 5, and 6. Right. 6, 3, 4, 5, 6. 7. That 0, 0, 1, 1. Still 7, 8, 9. 7, 8, 9. Okay. Corresponding to the XX3. Okay. And X, oh, Y, sorry, Y. That's a 0, 0, 1, 1, right? So from 7, 8, 9, that's a 0, 0, 1, 1, right? 7, that's 1, okay? 7, 0, 0, 1, right? That's 1. 7, 8, 9, 10. 0, 0, 0, 0, 1, 1. This one equal to 1. Okay, and then last two. 11 and 12, right? 11 and 12, that's 0, 0. 11 and 12, that's 0, 0. So 11, 0. 12, 0. Okay, so yeah, that's this one. Okay, 4. Okay, and then this one. We don't need the 8. We don't have 8. Then yeah, later I need to copy this too using this 4, right? Right. So we only 2 items, right? We only have 2 items. Okay, and Z. Z, that's equal 0, 1, 0, 1, right? The last, the right as the digit, okay, of the 8421. So 0, 1, 0, 1. And then still the from 0 to 2, okay, that's D, okay. D, this one D, right? 0, 1, 2, that's D, okay. And also the last three, 13, 14, 15, that's D. Okay, and then we start from 3. 3, that's 0, 1, 0, 1, okay. 3, it's equal to 0. Oh, sorry. 3 equal to 0. 4, sorry, this one's 3. And 4, 1, right? 0, 1. And then 0. Sorry. 0, 1, 0, this one, 1. Okay. 3, 4, 5, 6, right? 0, 1, 0, 1. 3, 4, 5, 6. And then 7, okay, corresponding to x3, 7. That's 0, 1, 0, 1. Okay, still 7. There's 1, 7, right? 0, 8, 1. 9, 0. And 10, 1. Okay, 0, 1, 0, 1. Then 11 and 12. 11, 0, and 12 equal to 1. 11, 0. That's 1, 1. Okay, so that's right. Let me okay. Maybe. Uh-oh. Right. Have to. Oh. Hmm. Open again, right? Sorry. Uh-oh. Have to okay, turn off the have to turn off the PowerPoint and then turn on again. Sorry, you have to wait a second, right? Then let me turn on the PowerPoint first. Okay. Right, and then share that again. No. Okay, yeah. Right, can see the visual, right? All right, so now this one. Oh, the last one. Oh, we have to fill it again. Huh. Sorry. And but we still have time, so we could finish the K-map, right? So go back to do it again, right? From Y, okay? Start from Y. So 0, 0, 0, 1, 1, okay? And at the first three, that's D, okay, and 0, 0, 1, 1. Okay, and then next one, 0, 0, 1, 1, 0, 0, 1, 1, right? And this one, 0, 7, 8, 9, 1, and 10 equal 1. And then 0, 0, 1, 1, 0, 0, 1, 1, and 0, 0, okay. And this one equals 0. And then 0. And the other three equal to 1. Right, and that also finish the last one first, right? 0, 1, 0, 1. First three, that's a 0, D, 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 right? And then 0, 1, 0, 1, right? And then 0, 1, 0, 1, 0, 1, 0, 1. That's a 7, 8, 9, 10. So 7, 0, 1, 0, 7, 8, 9, 10, 11, and 12. That's 0 and 1. Okay, so let me copy this one. Put it in the bottom. Okay, this one. On the top, right? So that's 8, but it's just on 1, right? Okay, and then we don't need the center one, right? We don't need the center one because that's we circle the 8, okay? We circle the 8. And maybe you could circle this 4 only, right? If you want, you just circle this 4. So the best one, that's 8, right? We choose the 8 or just 1. Okay, so top and bottom, the top and bottom. And for this one, we have to circle the center. Okay. No, there's 8, sorry. Okay. We don't need this 8. There's 2, I will use it for later. Okay, just, okay. This one, put it in here. Right? So there's 2, copy. And then better save it first. otherwise it will disappear again. Right. And back to our W and X, right? Go back to our W and X. This, and then I just so okay, that's okay. Yeah, just go back. So that's it, right? That's it. So we just go to our PowerPoint, right? Go to our PowerPoint. Okay. Okay, go back to our PowerPoint. Okay, but this 4, it's a adjustment, so we just treat it. Don't forget, okay, because I I didn't copy that one, so yeah, this 4, it's a adjustment. So we start from the W, okay, we start from W. So there's 2. Only A and B, right? A and B, no change, okay? A and B, no change. and then C and D are changed, right? C and D are changed, so we eliminate C and D. So for this four adjacent, that's A and B, okay? A and B. And then for this two adjacent one, let me see. CD no change, okay? CD that's 1 1 no change. And then 8 no change, okay? 8 no change. Only change B, right? Only change B. So that's ACD, okay? ACD. Hey, that's ACD, okay? And that's a W, right? That's W. If I do it wrong, then you have to remind me, okay? And then there's one X, okay? X that's for the four, okay? We start from the four adjacent one. Okay, that's four. That C bar no change. Okay, C bar no change, and then B bar, and also B bar. Okay, and also B bar no change. Right, B bar. So B bar, C bar, right? B bar and C bar, but I can put bar. So I use prime. Okay, I use prime. B prime C prime. And no, and then that's the first item, right? That's this one. And this one, it's CD, okay? CD, BCD, okay, BCD. So, where in here? BCD. And the last one, that's A, okay? A, no change, right? S, no change. And then ACD bar. You put it, that's the last one. ACD bar. Okay, we use prime. So that's X, right? That's X. And then Y, only two items, right? Only two items. And the other we just done this one, we just treat it like 0, 0. So for this two, for this four, only C bar D, right? C bar D. AB is changed, okay? ABR changed, so we can eliminate A and B. So only C bar and D. Just use C prime D. Okay, plus the bottom one. That's CD bar, okay? CD bar. CD prime, right? And there's two, there's eight, that's an 8, okay? 8 adjacent. So we could eliminate 3. Okay, so AB is changed, right? APR changed, so we eliminate A and B. And top and bottom, only D bar, no change, right? Only D bar, no change. C is changed, right? C from 0 to 1. So we eliminate C. So only D bar, D prime. Okay, so that's XX3 to A421. Okay, XX3 to A421. So you get just like last, you have to add it by yourself. Okay, add 2 bar on top of it, and then convert it into NAND gate, right? NAND. Okay. So the next step, I finished the. Let me see. In here, okay. For the first one, fill into KMap, right? And then find the SOP, right? Sum of product. Okay, I find the sum of product. So next step, you have to reduce them to NAND, right? Reduce the Boolean from to NAND, and then draw the circuit, right? Use NAND gate to draw the circuit, and then implement the circuit on multisig, right? Implement on multisig. Just like last week, I did this one. Okay, just like I did this one. Okay, on the multi-sync, and then use the word generator for the input, and use 4-channel oscilloscope for output, right? So you could check from the how to use it, how to implement the circuit in multi-sync. Then you could check the video. I think I already put the video on the titanium, right? So you could go to see the video. It's just about the different, okay? But the different the equation is different, okay? The equation is different, so you have to follow the equation, and also you have to convert it into this form, okay? This one, right? Yeah, just like you put it in here, right? And add 2 bar and convert it into this form, right? You have to convert it into this one, and then use this form to implement your circuit, okay? So that's I already finished the first step and second step, the hardest one. So you get the rest of it, step 3, 4, 5, you have to do it by yourself, right? And now it's 9:50, right? 9:50. So any question? Huh? Any question? So at the first one, right, you have to fill the table. Okay, you have to fill the table, just like exit 3 to A421, okay, A421. That will be just like I did, right? So that's yeah, see in here. So 0 is corresponding to 3, right? 0, that corresponding to 4, and 0 to 5, right? 0 to 6, okay? 3, 4, 5, 6. So 0, 0, 0, 0, right? So that's why in here. 0, 0, 0, 0. Okay, so for W, right? And the second, the following 0, 0, 0, 0, right? And this one still 4, no, not 4, 7, 8, 9, 10, still 0, 0, 0, 0, right? So 7, 8, 9, 10, still 0, right? And come back there. 11 and 12. Okay, 11 and 12, right? That's 11, okay? So that's supposed to be change the, yeah, just copy, okay, just copy. All right. Okay, that's 3 to 12, right? 3 to 12. And then 0, 1, 2, okay? 0, 1, 2, we don't care. And 13, 14, 15, we don't care, right? Just put don't care. So that's, yeah. So we start from, right, okay, so, yeah. And the second one, X, 0, 0, 0, 0, right? 3, 4, 5, 6, and then 7, 8, 9, 10. So that's 1, 1, 1, 1. So you can see it. 3, 4, 5, 6, right? Let me check it. So I might make a mistake in this one. Check it again. 3, 4, 5, 6, 7, 8, 9, 10. That's 1, 1, 1, 1, right? 7, 8, 9, 10. So this one's supposed to be, oh yeah, X, right? Sorry. Yeah, X, right? 0, 0, sorry, 0, 0, 0, 0, right? And then 7, 8, 9, 10. 1, 1, 1, 1. That's correct, right? and 11 and 12. 0, 0, okay? 11 and 12, that's 0, 0. So go back to here. 11, this one 11, and 12, okay, 0, 0. And the other 3 is don't care, okay? So for y, that's from 3, right? So start from 3. 0, 0, 1, 1, okay? Start from 3. 0, 0, 1, 1. That's correct, right? And then 0, 0, 1, 1. That's corresponding to 7, 8, 9, 10. 0, 0, 1, 1. Okay. 7, 0, 0, 1, 1, right? And then 11 and 12, 0, 0. Okay. 11 and 12, that's 0, 0. So 11 and 12, 0, 0. Yeah, and the other just don't care. So we only circle this 4, right? And also this 4. So that's correct, right? That's correct. So that's what the equation equal to C prime T or CT prime. And then the last one, 0, 1, 0, 1. That's a 3, 4, 3, 4, 5, 6. So 0, 1, 0, 1, right? And then 7, 8, 9, 10, 0, 1, 0, 1. 7, 0, 1, 0, 1. 7, 8, 9, 10, right? And the last two, that's 0, 1. 11 and 12. 0, 1. 0, 1. Okay, so that's correct, right? That's correct. So that 8 are just 1. So that we got Z equal to D prime, right? Z equal to D prime. Okay, yeah, we have now 56, right? We have 4 minutes break, then I will come back and then we have a quiz, right? Have a 4 minutes break, right?